Alright, so this video is going to be about neutral versus charge. Basically, I'm going to be focusing on what atoms are. So that kind of brings me to my next question. We're going to do a quick review on what an atom is. So that is the question. What are atoms? Alright, so let's go ahead and get started. Atoms basically consist of tightly bound subatomic particles known as neutrons and protons. And they are so tightly bound together in what is known as the nucleus of an atom. Okay, and orbiting the nucleus of an atom are electrons. But before we actually talk about the electrons, we're going to just really focus right now real quick on the nucleus. So the nucleus consists of neutrons and protons. All right. In order to, you have to understand that these neutrons and protons are pretty much in a commitment together. And they're in for the long run. They're kind of like a marriage. You know, they are tightly bound and they are not easily separating. You cannot just take a proton out of here and go on your merry way. You can't just take a neutron and go on your merry way. If you do that, that is known as splitting an atom's nucleus. And this split is called nuclear fission. Okay, and this nuclear fission causes so much energy to be released that it can be very devastating. We see this in what is known as nuclear bombs, okay? And that is really bad. We don't want nuclear bombs. So you're not going to just be splitting protons away from the neutrons. Not easy at all. All right, if you're going to do it, we all know it's going to release lots of energy. Okay, so we don't want that. Now I did speak a lot about, how this right here, the neutrons and the protons, are kind of in what we know as a marriage. Now let's talk about the more fickle, easygoing relationship, that of the electrons. The electrons are in as tight of a commitment. They are really easy. They're very loosely bound. They're orbiting the nucleus. As you see, they kind of go around it. It doesn't look like this. It really looks like a big old dust cloud. But just for the sake of theory, we're going to draw it like this. So the electrons are not, they just have no commitments. If they don't want to be attached to this nucleus over here, then they really do just leave and go on their merry way. They go on to another atom. They attach themselves to another atom's orbital, electron orbital, and, continue to orbit that atom. And when they leave, if these electrons leave, then it leaves this one, all of a sudden you don't have an electron, and, it changes this atom into what we call an ion. Okay, it's no longer an ion. When it's an atom, that means it's balanced. It has the perfect number of protons, the same number of protons and electrons. It is an atom. But when they leave, or if you gain another electron, then it is known as a cation, I guess. Well, not a cation. Let's not even go into that. We're going to just stick to, what I'm really going to just stick to is basically the charges of the atoms and the protons and neutrons and the electrons. So let's get on with that. So here are some of the charges. Okay, you have the neutrons, which have no charge. That's what the plus and the minus stand for. They are equal, zero, balanced charge. They have no charge on them at all. Okay, and then you've got the protons, which are a positive charge. And then you have the electrons, which are a negative charge. So let's just go back to the whole idea. If you happen to gain another electron, what happens to this ion? Does it become more negative or does it become more positive? Hopefully you said it becomes more negative. It has an overall negative charge because we just gained an electron. Okay? But on the flip side, if I was to, let's say, erase or get rid of an electron, did this thing become more positive or more negative? And hopefully you notice that it became more positive because, remember, electrons are negative. So if you want to make it more positive, then you have to get rid of an electron. If you want to make it more negative, you have to add an electron. So I'm going to just spell that out real quick. So this is very important that you understand. If you want to make an atom more negative, you need to add electrons. Why? Because electrons are negative. Right? And if you want to make it more positive, you have to subtract electrons. So if you're subtracting a negative, then you're going to have an overall positive charge. Okay. Before I finish, I also want to just bring this one to light. Can you also do this right here? So if you want to make it more positive, can you add more protons? That sounds pretty logical. If I want to make it positive, protons have a positive charge, right? Why not add more positive, more protons? Can you do that? Remember, let's go back to our original picture here. No, you can't do that because remember, protons are in the center of the nucleus, and if you're going to be adding a proton, that means you're going to be splitting a nucleus and you're going to be causing a huge boom, okay? And we don't want that. Booms are bad, okay? So you cannot add protons. No, you can only add or subtract electrons because remember, electrons are fickle. They can easily move and go on to somewhere else. They have no commitments. They can just peace on out, okay? Hopefully that helps you understand the neutral versus charged. Here is another quick rundown of the things that you just can't do. I'm going to just shoot this off real quick. So, first, you cannot add protons to make it more positive. Why? Because if you do that, you are splitting the nucleus. You cannot split the nucleus. Okay? So, yes. Moving on. You cannot add positive electrons. What's wrong with that? Can you add a positive, negative? Like, can you have a positive, negative at the same time? No. Then that means you have no charge. You know, because remember, electrons are negative. There is no such thing as a positive electron. That's kind of like saying I'm going to have light and dark in the same place at the same time. Okay, we got that. How about adding more neutrons to make it more positive? There's two things wrong with this. One, you cannot add a neutron. Why? Because it's in the center of the nucleus. You would be splitting the atom yet again, the nucleus. You can't do that. So, no. And then the other thing is, you can't make it more positive by even doing that. If you could do that, you couldn't make it positive. Why? Because neutrons have no charge. All right? So, go check your notes. If not, re-listen to this or go look at the picture that I drew, this beautiful masterpiece, and you will see. Neutrons, no charge. Okay? Protons, positive. Electrons, negative. The end.